Implicit differentiation. This section explains the distinction between the explicit function and the implicit function. It also explains how to use implicit differentiation to find the derivative of an implicit function. Explicit function. A function y equals to f of x is an explicit function of x if the dependent variable y on the left is given explicitly by an expression on the right involving the independent variable. So here are some examples. Y equals to ax squared plus bx plus c. Y equals to x squared minus 9 over x plus 3. Y equals to square root of x squared minus 4. Implicit functions. An equation in which the function y is not written explicitly in terms of independent variable x is called an implicit function. Example, x squared y squared plus 2xy equal to y squared plus x. Y equal to cosine of xy. Y equals to e to the xy. Rules of differentiation. The derivative of function involving independent variable x. For example, d over dx of x to the n is n times x to the n minus 1. But the derivative of function involving dependent variable y, d over dx of y to the n, is n times y to the n minus 1 and dy over dx. So for independent variable, you do not have to write dy over dx. But for a dependent variable, you have to write dy over dx at the end. So next is d over dx sine x is equal to cosine of x, while d over dx the sine of y is equal to cosine of y minus times dy over dx. Next, d over dx of cosine of x is minus sine of x. But d over dx of cosine of y is minus sine of y times dy over dx. d over dx of tangent x is secant square x. But d over dx of tangent y is secant square y dy over dx. d over dx of secant x is secant x tangent x. But the d over dx of secant y is secant y tangent y dy over dx. d over dx of cosecant x is minus cosecant x cotangent x. But d over dx of cosecant y is minus cosecant y cotangent y dy over dx. d over dx of cotangent x is minus cosecant square x. But d over dx of cotangent y is minus cosecant square y dy over dx. Implicit differentiation guidelines. Number 1, differentiate both sides of the equation with respect to x. Number 2, collect all terms involving dy over dx on the left side of the equation and move all other terms to the right side of the equation. Number 3, factor dy of dx out of the left side of the equation and then isolate dy over dx. Example 1. So let's find dy over dx using implicit differentiation and then find the slope of the graph at the given point. So tangent x plus y equals to x and the point is 0, 0. So let's start with tangent x plus y equals to x. So guideline number 1 says that this differentiate with respect to x. So we put dy over dx and tangent x plus y and equals to dy over dx of x. Now tangent is not tangent x, it's not tangent y, it's tangent x plus y. So we apply the chain rule, which is this the chain rule. d over dx or tangent u is secant square u times du over dx. Okay, so now apply this on this one, so we can write tangent becomes secant square, but just keep the x plus y, but at the end multiply with the derivative of x plus y with respect to x. And on the right side, derivative of x is simply 1. And now we apply here the sum rule of differentiation. So just retype secant squared times x plus y and write this as d over dx of x plus d over dx of y and equals to 1. Okay, just copy again secant squared x plus y. And this becomes 1 and this becomes dy over dx. And the right side is equal. Now we divide secant squared x plus y both sides. So we will get here 1 plus dy over dx equals to 1 over secant squared of x plus y. But we know 1 over secant u is cosine u, so we can change this to cosine squared x plus y. And now move the 1 to the right as minus 1. So you can rewrite negative 1 plus cosine squared x plus y. So we can factor negative 1, so you will have 1 minus cosine squared x plus y. Now, Pythagorean identity, sine squared theta is 1 minus cosine squared theta. So this we can change to sine squared theta. So you have a sine square minus sine squared x plus y, and the point is 0, 0. So now we substitute x equal to 0 and y equal to 0. So we'll say slope is dy over dx minus sine squared 0 plus 0. 0 plus 0 is 0, sine squared 0. Sine is 0, so sine squared 0 is also 0. So the slope is 0. Example 2, find dy over dx for y cubed plus y squared minus 5y minus x squared equals to negative 4. So let's write down y cubed plus y squared minus 5y minus x squared equal to negative 4 and differentiate with respect to x. So put d over dx and write down y cubed plus y squared minus 5 minus x equal to d over dx of negative 4. Now we apply the sum of difference rules on the left side, so we can break it down into d over dx of y cubed plus d over dx of y squared minus 5 and d over dx of y minus d over dx of x squared. And the right side, the derivative of negative 4 is 0 because negative 4 is constant. Now we apply this d over dx y to the n equals to n times y to the n minus 1 dy over dx formula. So using this power rule, d over dx of y cubed becomes 3y squared times dy over dx. The d over dx of y squared becomes plus 2y dy over dx. And then you have a minus. So find the dy over dx minus the derivative of x squared. There will be negative 2x. Okay, now we move the negative 2x to the right side and factor out dy over dx from these three terms. Okay, so we have 3y squared plus 2y minus 5 and dy over dx is factored out and 2x moved to the right side. Now I just divide 3y squared plus 2y minus 5 on the other side. So dy over dx is isolated, we get 2x over 3y squared plus 2y minus 5. Example 3. Determine the slope of the graph of 3 times x squared plus y squared equals to 100xy at the point 3, 1. So let's start with 3 times x squared plus y squared to the power 2 equals to 100xy. Let's differentiate with respect to x. So this becomes d over dx of 3 times x squared plus y squared equals to d over dx of 100xy. So on the left side, we're going to use the chain rule, and on the right side, we use the product rule. So we have then 3 and bring down the power 2, multiply with 3, and this becomes x squared plus y squared to the power 1. But then multiply with the derivative of the inner function, x squared plus y squared equals to 100. So here we apply the product rule, so it becomes x times d over dx of y plus y times d over dx of x. Okay, now if we simplify, 3 times 2 becomes 6, we type x squared plus y squared, and here this we break it down into two derivatives using some rule of differentiation. So we're going to d over dx of x squared plus d over dx of y squared equals to 100 x times dy over dx plus y times dx over dx is 1. Okay. Now just copy down again 6 times x squared plus y squared. Write down the derivative of x, which is 2x, and the derivative of y squared is 2y dy over dx equals to 100 x times dy over dx plus y. Okay, so we distribute 6 times x squared plus y squared into 2x plus 2y dy over dx and 100 into x times dy over dx plus y. So we multiply this into 2x, you get 6 times x squared plus y squared times 2x, and then 6 times x squared plus y squared times 2y dy over dx becomes 6 times x squared plus y squared 2y dy over dx equals 100 times x times dy over dx plus 100 times y. Now we can simplify, we can multiply 6 into 2x becomes 12x times x squared plus y squared. 6 times 2y is 12y times x squared plus y squared dy over dx. And right side 100x dy over dx plus 100y. Now we move this term, it doesn't have dy over dx, to the right side, and this have dy over dx, we move to the left side. So we'll have minus 100x times dy over dx plus 12y times x squared plus y squared dy over dx. On the right side we have 100y and 12x times x squared plus y squared. Okay, so we factor dy over dx on the left side, so you will have minus 100x plus 12y times x squared plus y squared dy over dx. And we just copy this one, 100y minus 12x times x squared plus y squared. So now we divide both sides by this term, left side, this, so this cancel out. So we'll have, okay, so now we have dy over dx equals to 100y minus 12x times x squared plus y squared over minus 100x plus 12y times x squared plus y squared. Looks like if we can factor 4, so we'll have 4 times 25y minus 3x times x squared plus y squared. And on the bottom we have 4 times minus 25x plus 3y times x squared plus y squared. Okay, so 4 we can cancel out, and we have left with 25 minus 3x times x squared plus y squared, and minus 25x plus 3 times y times x squared plus y squared. So now we substitute, x is 3 at this point and y is 1. So this becomes 25 times 1 minus 3 times 3 times 3 squared plus 1 squared. And over minus 25 times 3 plus 3 times 1 times 3 squared plus 1 squared. So now we simplify. 25 times 1 is 25. 3 squared is 9, 1 squared is 1. So it becomes 9 plus 1 is 10. 3 times 3 is 9. And over negative 25 times 3 is negative 75. Plus 3 times 1 is 3. 3 squared is 9 plus 1 squared is 1. So 10. So now we have 25 minus 90 and minus 75 plus 30. Now 25 minus 90 is minus 65 and minus 75 plus 30 is minus 45. Now we can divide both these numbers by negative 5, gives you 13 over 5, and that's the slope of the tangent to this curve at point 3,